Alright, Part 2, Module 7, Chapter 2, Part 2. Transistor specifications. Transistors are available in a large various shape of the size, with each of its own unique characteristics. Each of the transistors usually present with the specifications chief they may be included with the transistor manuals, although the main property for the transistor could be specified with the sheet the manufacturer list, and only some of them specific listed vary differentiation in manufacturer type, the transistor application of the transistor, the specification usually covered the following terms. Items. The general description of the transistor include the following information: the kind of the transistor that cover the material, either the germanium, zirconium, or silicon. So the type of the transistor, negative, positive, negative, the construction of the transistor, whether alloy or junction, ground or diffuse junction, etc. Some of the common applications for the transistor with such audio amplifier, oscillator, radio frequency amplifier, etc. And general sales of the feature for the side of the package of the mechanical data. The absolute maximum ranges of the transistor direct voltage of the current value that they exceed the operation that may result with the transistor failure. The maximum of rotating will usually include the collector of the base of the voltage, the emitter base voltage, collector current, emitter current, and collector power dissipation. The typical operating value of the transistor value of the present only as a guide of the values vary widely depending upon the operating voltage, also upon which of the elements are commonly in the string with the various listed, include the collector, emitter voltage, collector current, and input resistance, load resistance, the current transfer ratio of another name of the alpha beta. Collector cut off the current with the leak of the current of the collector to the base with no emitter with the current with the supply with the transfer characteristic. The covers may also be included with the section A of the transistor current covers the graphing plot on the relationship between the currents and voltage. Then a circle with more than one of the curves on the graph is called the family of the curves. And additional information for the engineering design purposes. So far, many letters and abbreviations, the terms have been introduced. Some of the frequently used, other only rarely used. For the complete and all semiconductor letters assembled in terms of the refer to the EMIB series. 000100 Section 3 Transistor Identification. The transistor can be identified with the joint arm name of the designation printed directly on the scale of the transistor, making it simple to explain with the earlier of the diodes used for the transistor identification. The first number to indicate the number of the junction letter N for the following. The first number that tells you with the component of the semiconductor. Figure 2 and 3 the digit for the following with the N. The manufacturer identification number. The last number that followed by a letter indicates the letter improved the version of the device. So for the example, the semiconductor division designated with the 2N130A with the signified with 3-element transistor semiconductor material improved version type 130. Alright, number of junctions versus semiconductor identification number in the first modification. You also find other modification transistors that do not relate with the JAN and marking system. These marking with the manufacturer identification may conform to the standardization system. If in doubt, will always replace with the transistor with one of the identical markings. Ensure the identical replacement of the current substitutable substituted for the console and an equivalent transistor manual with the specification on the transistor maintenance of the transistor are very regular, except with the relatively trouble-free with the encapsulation conforming the coding. The technique with the probably extremely light with expecting the theory with the transistor should leave the last identify how with the transistor shut with the current overload with the junction will be damaged, even destroyed. In addition, for the application with extremely high operating voltage can damage and destroy the junction of the arc over the excess of the reverse current. One of the greatest danger of the transistor in the heat will cover the excess of the current flow with the eventual destruction of the transistor. Determine the transistor good or bad. You can check with the ammeter with the transistor tester. If in many of the cases the substitute for the transistor known to be good for that is questionable, thus determine the condition of the suspected transistor. The method of testing is highly accurate. Sometimes the quickest decision should be only with the after you make certain that there are no circuit defects that might damage the replacement of the transistor. If there are more than one defective transistor present with the equipment, you will have the trouble of having been localized. With the testing method becomes common. Some of the several transistors may have to be replaced before the trouble is correct. With determining which stage the failed, which of the transistor non-effective. All to remove the transistors must be tested. This test can be made by using the standard Navy ammeter transistor testing. Observed whether equipment operated correctly in each of the removed transistor and reinserted into the equipment. A word with the caution in discriminating substitution of the transistor. Critical currents should be avoided when the transistor soldered equipment into the equipment. The substitution is not practical. Generally desirable to test the transistor in their circuit. The precautions: transistors, although generally move with the rough mechanically electron tube, is susceptible to the damage of electrical overhead, the heat of the humidity, radiation damage of the nature of the often occurs during the transistor circuit, implying incorrect polarity voltage collector circuit with excessive voltage of the input circuit with the careless soldering technique for the overheat of the transistor have also been known to cause considerable damage. One of the most frequent causes of the damage to the transistor is the electrostatic discharge from the human body when the device is handled. You may avoid some of the damage before starting the repairs by discharging the static electricity from your body by chassis and container of the transistor. You can also you can do this simply by touching the chassis. Thus, the electricity will be transformed from your body to the chassis before you handle the transistor. To prevent the transistor damage, avoid the electrical shock. You should observe the following precautions when you are working with the transistorized equipment test. The equipment soldering irons should be checked to make certain that there is no leakage current from the port source. If the leakage current is detected, isolation transformers should be used. Also, the current ground test of the equipment is circuited before attempting to inject the monitoring its signal. Ensure test voltage do not exceed the minimum allowable voltage of the circuit component of the transistor. Also, never to connect the test equipment output directly with the transistor circuit. Meter range of the required of the current of more than 1 milliamp. The test circuit should not be used for the transistor. The battery eliminator should not be used to furnish the power of the transistor equipment because they have poor voltage regulation, possible high ripple voltage. The high heat applied with the transistor when soldering connections required should be kept to a minimum by using low wattage soldering iron or heat shunts or long nose pliers on the transistor leads. When it becomes necessary to replace the transistor, never pry a transistor loose from them printed on circuit boards. All circuits should be checked with a defect before replacing a transistor. Power must be removed from the equipment before replacing the transistor. Use conventional test probe with the equipment to closely space parts often even cause the accidental shortage between adjacent terminals. These shorts rarely cover the damage of the electron tube, but may ruin the transistor. To prevent these shorts, the probes can also be covered with the insulation, except for the very long length of the tips. Lead identification. The transistor lead identification plate with the important play of the part of the transistor maintenance. To cover the before of the transistor can be tested. The replay for the lead of the terminals must be identified. Since there is no standard method of identifying the transistor lead, it's quite possible to make one lead for another. Therefore, when you are placing the transistors, you pay close attention to how the transistors mount with particular to those transistors on the soldered end, so that you do not make a mistake when you are installing a new transistor. When you're testing the replay for the transistor, if you have doubts of the one lead which the console with the equipment of the manual transistor manual show the specification for the transistor being used. There are, however, the simple typical lead identification schemes that will be very helpful for the transistor troubleshooting. These schemes are shown in Figure 217. In the case of the overall shape, the oval shape of the transistor shown with the view A with the collector lead identified with a wide space between it and base lead with the lead short farthest from the collector in line with the emitter lead with the leads for the evenly spaced with the in line shown in View B, color dotted with usually red with indicate the collector with the transistor, round with the view C with a red line indicate the collector, the emitter lead with the shortlisted lead. View D leads are in triangular arrangement. They offset with the center of the transistor lead, the opposite of the blank quadrant in the scheme. The base lead with the view base to from the bottom of the collector. The first lead with the clockwise from the blade base. Leads view E are arranged with the same manner as over the view D, except for the tab of the view. Identify the lead of the view base bottom of the clockwise direction. First lead the following the tab. Emitter is followed by the base for the collector. Emitter and collector base. Emitter collector dot base collector. In convention with the power transistor shown views F and G collector lead with the usually connected within the mounting base for the further identification of the base lead with the view B with the cup with the grease sleeving with the lead with the view G identified with the viewing transistor from the bottom in the clockwise direction with the mounting holes occupying 3 o'clock, 9 o'clock position. Emitter lead will be either 5 o'clock or 11 o'clock position. The other lead is the base lead. The transistor testing. There are several different ways of the testing of the transistor. The testing, while in the circuit by the substitution method mentioned with the transistor tester and ammeter, the transistor testers are nothing more than solid-state equivalent in electron tube testers. Although they do not operate with the same principle of the most transistor testers, it is possible to test the transistor in and out of the circuit. Therefore, the basic tests require the transistor practicable troubleshooting, gain leakage, and breakdown and switching time. For the maintenance repair, however, the check of the 2-3 parameters is usually sufficient to determine whether the transistor needs to be replaced. Since it's impractical to cover all the different type of the transistor testers, since each of the testers comes with its own operator manual, will move only on something you will most likely frequently for testing transistor ammeters. Testing transistor with an ammeter. 2 tests can be done with the ammeter. Again, with the junction resistor test with the transistor junction resistor to reveal the leakage and shorted open the transistor. Gain set of the basic transistor gain set can be can be made by using the ammeter with a simple test circuit. With a test circuit that can be made with just a couple of the resistors to the switch, and shown in Figure 250-18. The principle behind the test live with in fact the little of the no current will flow in the transistor between the emitter and the collector until the emitter base junction and forward base bias. The only precaution you should observe is with the ammeter. An internal battery may be in the meter provided that it does not exceed the maximum collector emitter breakdown voltage. With the switch in figure 218 with the open position with the shown with no voltage applied with the positive negative power of the transistor base, the emitter base junction is not forward bias. Therefore, the ammeter should read with the high resistance indicator of the meter, which with the switch is closed with the emitter base circuit is forward bias. The voltage of the cross resistor 1 and resistor 2 current flow over the emitter of the collector circuit, which cover the lower resistance reading of the ammeter. The figure 10:1 with the resistance ratio of 10:1. The test between the meter readings indicate the normal gain of the auto frequency transistor testing of the non-positive negative transistor using the circuit. Simply reverse the ammeter lead and then carry out the procedure described earlier. Transition junction resistance test. Ammeter can be used with the used to test the transistor for leak with the undesirable flow of the current measuring of the base emitter of the base collector emitter forward and reversing resistance for simply a concern with the transistor under the untested each of the figure shown figure 219 view A and B and C. The two diodes connected back to the back, therefore each of the diode will low forward resistance, high reverse resistance. The measuring of these resistance ammeters show the figure that you can determine the transistor leak and the current through the junctions. When making these measurements, avoid the resistor 1 scale on the meter and meter on the high internal battery voltage. Either of these conditions can damage the low power transistor. Alright, now you can now consider the possible transistor problems that could exist indicating the reading figure 219 and obtain the list of the problems provided in the table 2.2. Resistant readings forward and reverse, low not shorted, the transistor is leaking, low shorted and then forward and reverse, the problem is shorted. If the resistance are high and forward and reverse, then the problem is open. By now, you should recognize with the transistor figure 219 view A and B and C, with the P positive negative transistor. If you wish to test the positive negative transistor leak with the procedure identical so that you the testing of the positive negative except with the readings obtained they're reverse. Your testing transmitter power with the negative. We should remember the actual resistance value depending on the meter scale with the vary voltage, typical forward reverse resistance, and significant. The best indicator shown with the transistor, good or bad, is the ratio forward to the reverse resistance. The transistor with the testing showing the ratio of 30 to 1 is probably good. Many transistors show a ratio of 100 to 1 or greater. Alright, microelectronics. Upon know the various semiconductor resistor capacitors in our discussion, the consider the separate package component with the discrete components of the section where we will introduce some of the more complex device for the complete circuit of the package in a single component. This device is referred to integrated with the circuit with this broad term that you describe the device of miniature electronic equipment is called microelectronics. With the inverter and transistor damage, the military special and other equipment, the design engineers set up with the miniaturized electrical equipment. The beginning of these efforts were frustrated because the most of the time, most of the components in the circuit that shows the resistor capacitors, coils, were larger than the transistor. Soon that the circuit components were miniaturized, they were pushing ahead of the development of smaller electronic equipment. Although long miniature resistor capacitors, other circuits elements of the production of the components of the were actually smaller than the space required for the interconnecting wires and cables became possible. The next step of the research process was eliminating the bulky wire component. This was accomplished with the printed circuit board. A printed circuit board is a flat insulating surface upon with the printed wiring miniaturized component with the connect with the predetermined design attached with the common base. Figure 220 view of the A and B shows the typical printed circuit board to notice the various components that are connected with the board with the printed wiring and the reverse side of the board. So the techniques are all interconnecting wiring in the place of each of the equipment except for the highest power leads and cables is reduced to line with the conducting material with the copper, silver, and gold deposited directly on the surface, insulating the circuit board. Since the printed circuit boards are readily adapted plug-in unit, eliminating the terminal boards, fittings, tie points, and not mentioning wires, result in substantial reduction overall size of the electronic equipment. Shows a picture of a typical printed circuit board. Reverse side, the wiring. After the printed circuit board were perfected, the effect of the miniaturized electronic equipment were then shifted to the assembly technique, which led with the modular circuitry within technical and printed circuit boards bound with the stacked and the connected together to form a module, then increase the package density of the circuit component, the result of the considerable reduction in size of electronic equipment. Since the module can be designed to perform any electronic function and also very versatile unit. However, the drawback to approach with the modules was recognized with the considerable number of the connections to take up with much of the space. The increase of the cost of the addition of the test should be reliable with the effect of the increase of the number of the connections. And a new technique was required to improve the reliability, further increase the packaging density. There was a solution with an integrated circuit board. The integrated circuit board is a device that integrates that combines both active component of the transistor and diodes, passive components for the resistor and capacitors for the complete electronic circuit in the single chip, tiny single wafer or semiconductor crystal insulator. The integrated circuits have also been eliminated to use the individual electronic components, resistor, capacitor, transistors as building block for the electronic circuit. Instead, they use tiny chips that have developed whose function they're not single part, but does in the transistor, resistor, capacitors, other electronic equipment, other electronic elements, and all interconnected perform the task of the complete circuit. The other compromised number of the complete conventional circuit stages, such as multi-stage amplifier, and one extreme smallest component of these chips are frequently monitored on a printed circuit board, as shown in Figure 221, which the plugs are into an electronic unit. Integrated circuit board, printed on the circuit board. Integrated circuits have several advantages over the conventional wired circuit. With the discrete component of the advantages include the drastic reducing of the size of the weight, the 2, the increase of the reliability, 3, lower cost, 4, the most possible improvement in circuit performance. However, the integrated circuits are composed parts, but so closely associated with another one, the repairs must be applied almost impossible in case of the trouble of the entire circuit is replayed within a single component. The basic two general classification integrated circuit boards are hybrid and monolithic. Monolithic integrated circuit boards element of the resistor and transistors associated with the circuits are fabricated and inseparable with a continuous piece of the material called the substrate. Usually silicone and monolithic integrated circuits are made of single transistor. One part of the crystal is being doped from the transistor. Other parts of the crystal are being acted upon by the associated resistor capacitor. All these elements of the complete circuit are created with the crystal by the same process within the same time that required for the signal transistor that produce the considerable cost saving over the same circuit made with the discrete components, lowering assembly costs. Hybrid integrated circuits are constructed somewhat differently, with the monolithic device of the passive component with the resistor capacitor with the on the substrate with the foundation made of the glass, the ceramic or insulated material. Then the active component of the diode transistor is attached with the substrate with the connected to the passive circuit. The component of the substrate using very fine 1/1000 of an inch wire. By the term of the hybrid refers to the fact that different process to form passive and active components of the device. Hybrid circuits are the two general types: thin film or thick film. Thin and thick film are referred to the relative thickness of the deposit material used to form the resistor. Other passive components of these thick devices capable of dissipating more power but are somewhat more bulky. Integrated circuits are being used in every increasing variety of the application. Small size of the weight with a high reliability, more ideally suited for the airborne equipment, missile systems, computers, spacecraft, portable equipment. They often easily recognized because of the unusual package that contain the integrated circuit. The typical packaging source of the shown Figure 222 with the tiny packages protected with a help dissipated the heat energy generated of the device. On these packages, the may contain one of several stages that having several hundred components. Some of the most common packaging styles are shown in Figure 223. Our 222 show the typical integrated circuit packaging: copper, wire-bound binding, isolated IC, unsoldered base glass leads, ceramic glass cover, IC CP chip bonding, gold backing, aluminum bonding wires, metal adhesive, chemical, ceramic mounting base, golden metal plated external leads. Common integrated packaging styles: A flat, B line, and C. T05. The preceding form and information was presented to give you the brief and introduction of the integrated circuit. If you wish to pursue with the subject, further additional information is available in your ship or station's library. Alright, Chapter 2 Summary.